to imagine that you're a teacher trying to write an exercise for a textbook. If you want your textbook not to be boring, you're going to want to have a variety of answers. In other words, the questions won't all be the same. Now, for the quadratic exercise, you probably know that sometimes you get two answers. This one has two answers, 3 or -3. Sometimes you get no answers. So this quadratic equation has no solutions because you can't ever get a negative through squaring. And sometimes you just get one answer. So for example, x squared equals 0. That just has one answer. Okay, so if sometimes you have one answer, sometimes you have two, and sometimes you have three, and you want a nice variety of those throughout your exercise, how do you design your questions in order to achieve that balance? Well, here's the thing, and this is what this topic is all about. When you are writing a quadratic equation, whether it's this or this, or this, what determines how many solutions there are is b squared minus 4ac. And the reason why I drew those ones in is because the a is the coefficient of x squared, the b is the coefficient of x, and the c is the number that's not multiplying by x, just the ordinary constant number on the end. So b squared minus 4ac for this, top one, is -4 squared minus 4 times 1 times 3, which is 28, I think. For this one, it's 25 minus 28, which is -3. And this one here is -5 squared minus 4 times 1 times 0. There's no number adding on there, so that's why it's 0, so that's 25. And here's the rule of thumb. If this thing, b squared minus 4ac, comes out positive, your answer will have two solutions. Okay, now by the way, there's a name for this, it's called the discriminant, and it has a abbreviation which is a little triangle. So in other words, if the discriminant is properly positive like 25 or 28, you will get two solutions. If the discriminant is negative, you will get no solutions. And finally, if the discriminant is 0, you will get one solution. So that leads to the classic question for you, because you're not writing a textbook, you're just trying to answer these questions. So a classic question is this: find k such that x squared minus kx plus 4 equals 0 has just one solution. Okay? Well, if it's just got one solution, the discriminant has to be equal to 0. What is the discriminant? It's b squared minus 4 times a times c. So k squared minus 16 equals 0. So k equals 4 or -4. In other words, the teacher has two options. If based on this basic setup, the teacher wants to write a question that has only one solution, they've got two options. One is this. That's what I wrote. That's where I put a 4 where the k is. And the other option is this. That's where I put a -4 where the k is, and the double dash leads to the positive 4 there. So again, this is to return to the original point. Imagine these are for a teacher trying to write a question that has all sorts of different answers. What we've just discovered is that if this is your basic template for a quadratic equation question, if you're determined to use a 4 and just have a hidden one there, and if you want to have just one solution to your equation, well, you better put that as either 4 or -4. I'll give you another example. What if it was, I don't know, x squared plus mx, and you want it to have two solutions? Well, if you want it to have two solutions, then b squared minus 4ac has to be positive. So in other words, b squared minus 4 times a times c had better be positive. So m squared had better be positive. So in other words, m can be anything that isn't equal to 0. So no matter what you do here, as long as m isn't 0, you get two solutions, whether it's that, or this, or this. You will always get two solutions to the quadratic equation that you design.